video, let us see what is magnetic flux. According to Michael Faraday, magnetic field and electric field can be represented by field lines. First, let us see what is magnetic field lines. It's a bar magnet. If you keep a unit north pole here, this north pole will repel and this south pole will attract. So it will move along this direction. So magnetic lines of force is the direction along which a north pole will tend to move if it is free to move. So if you keep a north pole here, you can imagine, you cannot have a north pole alone. So you can imagine a north pole. North pole will be repelled by this north pole, so it will move along this direction. This south pole will attract. So these are the magnetic field lines due to a bar magnet. Outside it is magnetic field lines are from north pole to south pole, but inside it is south pole to north pole. So magnetic field lines are continuous curves starting from north pole and ending at south pole. Outside, but inside south pole to north pole. Then here you can see lines are crowded. So in a small area, large number of lines are there. So here strength of the field is more. So the degree of closeness of the lines determines the strength of the magnetic field. Here you can see large area, less number of lines. So here intensity of the field is less compared to this point. Then direction of the magnetic field at each point is given by the tangent drawn to that at that particular point. This is the direction of the magnetic field here. Here this is the direction of the magnetic field. Here this is the direction of the magnetic field. So the tangent will give you the direction of the magnetic field. Then field lines will never intersect. If this line is intersecting at this point, at that point there can be two directions for the magnetic field. So that's not possible. So magnetic field lines will never intersect. Then here you can see gap here and gap here is more or less same. So that means intensity of the field here and here is equal and direction is equal. So a uniform magnetic field can be represented by parallel lines. So magnetic fields are of two types: uniform magnetic field and a non-uniform magnetic field. So a uniform magnetic field can be represented by parallel lines. So this is a uniform magnetic field. So you can see direction is same and the gap here and gap here, everywhere it is same. So magnitude of the magnetic field and the directions are same. So uniform magnetic field. Here you can see it has got the same direction, but here gap is more, here gap is less, here once again gap is more. So it's not uniform. The magnitude of the magnetic field is not uniform, but the direction is same. If a magnetic field is to be uniform, it should have same magnitude and direction. But here you can see magnitude everywhere same, because as shown by the gap, here gap everywhere it is equal. So it's the magnitude of the magnetic field is equal, but the direction is different. Here this is the direction of the magnetic field, here this is, so direction is not same. So this is all example for non-uniform magnetic field. Here direction also different, here this is the direction here, so direction is not same, and magnitude are also not same. Here gap is less, here gap is more. So here in this case same direction but magnitude different. Here same magnitude but direction different. Here both direction and magnitudes are different. So these are all the example for non-uniform magnetic field, and this is uniform magnetic field.